Welcome to Sustained Silent Reading 7.2 Energy Transformations. System change as energy flows and changes from one part of the system to another. Parts of the system may speed up, slow down, get warmer, get cooler, or change in other measurable ways. Each change transfers energy or transforms energy from one form to another. Transforming energy. An example of transforming energy. An example of the flow of energy illustrated below. This example involves transforming chemical energy into electrical energy. Chemical energy, as fuel, is a gas called methane. It is burned in a chemical reaction, and the heat energy is released. The heat energy makes steam hot. This steam turns a device called a turbine, making mechanical energy. Finally, the turbine turns an electrical generator, producing electrical energy. You can attain this. Energy by plugging it into an electrical outlet. This picture here demonstrates what I'm talking about there. From high to low energy. We can predict how energy will flow. One thing that can always be sure of is that things tend to move from higher to lower energy. For example, at the top of a roller coaster hill, the car has more potential energy, figure 7.7. The potential energy is transformed to kinetic energy as the car rolls down the hill. Once it reaches the bottom, the car has less potential energy and is more stable. That's in this picture here. This picture here shows at the top of the hill it has potential energy. Then as the car moves down the ramp, it gains kinetic energy. At the bottom of the hill, a roller coaster has more kinetic energy. Without friction due to Newton's first law of motion, the car would roll in a straight line path forever. However, on a straight path, kinetic energy car usually decreases due to friction slowing it down. Friction transforms energy of motion to energy of heat, or the wearing away of materials on the wheels. The energy converted to heat or wear is no longer available as potential energy or kinetic energy. It is not destroyed. Next page. The flow of energy transformation. Suppose you are skating and you come to a steep hill. You know skating uphill requires energy. From your mass and the height of the hill, you can calculate how much potential energy you will have at the top, figure 7.8. You need at least this much energy plus some additional energy to overcome friction. Notice this picture. This picture here is showing you trying to roller skate up to the top of the hill. You can calculate your potential energy based on that. The energy you use to climb the hill comes from the food. The chemical potential energy stored in the food you ate is converted into simple sugars. Upon reaching the top of the hill, some of the energy you spent is now stored as potential energy because your position is higher than when you began. Some of the energy is also converted by your body into heat. Can you think of any other places the energy might have gone? Once you get to the top of the hill, you start to coast down the other side. Your speed increases. An increase in speed implies an increase in kinetic energy. That comes from the potential energy from climbing up the hill. Energy was saved and used to purchase a greater speed as you descend down the other side of the hill, figure 7.8. Kinetic energy is used up in the brakes. If you are not careful, the energy If you are not careful, the stored potential energy can generate too much speed, assuming that you want to make it down the hill with no injuries. Some of the kinetic energy must change into some other form. Brakes on your skates slow down and use up this extra kinetic energy. Brakes convert kinetic energy into heat by wearing away their brake pads. As you slow at the bottom of the hill, you should notice the brakes should be very hot and some of the rubber will be worn away. The flow of energy. During the trip down the other side of the hill, energy flowed through many forms. Starting with chemical energy, some energy appeared in the form of potential energy, kinetic energy, heat, air friction, sound, evaporation, and more. During all these transformations, no energy was lost because energy can never be created or destroyed. All of the energy that you started with went somewhere.